Let's go. Right, so we've still got 1 minute left or so, but hopefully we're started up now. Okay, looks like our video is on. So minimize that. Okay, everyone, so it's 5 o'clock, so welcome to our next edition of Greenfoot Live. So my name's Neil, I work on the Greenfoot team.
Hi everyone, my name is Hamza. I am a member of the Greenfoot and Blue Jay development team, and we are here actually to chat and talk about different aspects of Greenfoot in terms of pedagogy of teaching, and maybe any other. Also happy to answer any questions.
Yep. Yeah. So if you've got any questions, then just put them in the chat panel alongside the live stream, and we'll be taking a look at those throughout. But as Hamza said, today we thought we'd talk about some pedagogical issues. So Hamza is one of our newer team members, and so he was actually looking at a paper that Michael wrote about Blue Jay and its pedagogy. So those of you who don't know, Greenfoot is kind of built on top of Blue Jay. So a lot of the principles that apply in Blue Jay's pedagogy also apply in Greenfoot. And so we just thought it'd be interesting to maybe talk through some of those points that were raised there and talk about how they apply to Greenfoot and what that actually means for your teaching if you are teaching with Greenfoot. So that's our rough plan for today. So I guess we should get started.
Yeah, actually interesting about teaching programming that there are different approaches actually to teach programming.
Certainly, yeah.
And over the time, actually, people found out that there are some guidelines that should be followed in order to adapt a good approach for teaching for the students to learn about programming. So, for example, the concept of objects first is really useful, which means that the students actually will think about the program as a concept of classes and objects, and how they interact with each other, rather than putting the students straight away into the syntax and then start reading and writing code which they found difficult. But when they actually start thinking about the objects in terms of how the whole world is actually compound of different classes or different objects, they will find it more interesting and they can understand the benefits of object-oriented. Greenfoot actually applied that and also Blue Jay applied that very clearly. Well, if you actually look into the, for example, Greenfoot you can see the classes, we can see the word screen where we can actually create instance of the classes, and those represent the objects. So here we have objects, we have things to work on. If we don't have objects, then that means we can't actually run the application.
Yeah, so maybe we'll talk through we've got the Greenfoot window on screen here. And so objects first is, as you say, part of our sort of core philosophy. And it comes from, what objects first means is a lot of teachers, when object orientation was newer, they sort of tended to teach by, they did imperative programming first, so they did variables, they did functions, and then towards the end of the course they said, oh, and here's objects. Which was often a reflection of how they'd learnt it, because when object orientation was new, that people learnt imperative first and then they learnt objects later on. And so Greenfoot and Blue Jay were kind of designed with in mind, well, what if we said here's objects first? So we didn't view them as an advanced topic that came at the end of the course, we viewed them as a topic that can be approached immediately. And so, as you say, in the interface we have deliberately designed it to make things apparent. So on the right hand side we've got this list of classes. You see I've just got my cursor over them here. We split them into the world classes, which is the background in Greenfoot, and then the actor classes, which are the things in the interface, and then on the left hand side we've got the objects. And so this was often a cause of confusion among students, is what's a class and what's an object. People get very confused about these two concepts, and they don't really understand that class sounds like object. They're both very abstract terms and they don't really get the difference. And yet here in Greenfoot, already in the interface, classes are the templates over here on the right, objects are the things on the left, And for any given class, we can create, how has he got his right click? Sorry, I'm using Michael's mouse today, so I'm trying to remember what right click is on his mouse. So for any given class, you can always make multiple objects. So here we've got one rocket class, two rocket objects.
Yeah.
So the interface is just trying to make it apparent, okay, the class is the template, the object is the actual instance.
Yeah.
And really sort of, hammer that home, but without even, making it too explicit or explanation. It's just, it's just implicit in the interface. It's just how it works, basically.
Exactly. Also, what is useful about the layout of the Greenfoot, that we have like the structure of the program on the right-hand side, where we actually see the classes and also subclasses and their implementations inside. And actually, this will help the student actually understand the main structure of the application and knows what are the main classes of the program, or actually the application that they work on, and this help them actually to write the right code and the right methods and the right properties in each class. So
yeah.
It's really useful. And one of the pedagogical approach actually is to show the students the structure of the program.
Yeah, and as you say, that when you start out with Greenfoot, you don't actually even need to touch the code to be able to interact with the system. So for any given object here, if you right click on it, you can then have access to its methods. So you can talk through concepts with students like methods, method calls, properties of objects. So we can also inspect the contents of a particular object. So you can talk through, the rocket has properties. It's got the X and the Y position, the rotation, there's several others, various images and things like that. So it gives you the chance to talk through concepts and structures without even needing to get to the code.
In a visual way as well. So showing these parameters in this actually dialogue, it really helps the students actually understand better, and it gives like some sort of conceptual map about the main parameters, main methods of the class.
Yeah, and also the nice thing is that, so we've got that inspector there, which was inspecting one of the rockets. If I now bring up a second inspector, is that the same rocket I inspected? I forgot which one's which.
Yeah.
Maybe I just need to inspect this one instead. There we go. Okay. So if I now bring up these two inspectors, we can see and talk through with the students the fact that they've got the same set of properties here. So they've both got, you can see reload delay count is one of the properties. It's on present in both rockets. So the sort of format and structure is the same, but the values can be different. So here you can see X and Y position of this rocket is different than the X and Y position of that rocket.
Yeah.
So again, we can talk through the difference between two objects, but their similarity by having the same class.
Exactly.
Without even, we haven't looked at any Java code yet since we started the video, but we're already able to talk through some concepts. And we can also bring up instead an inspector, misclicked, for one of these asteroids. And again, that allows us to talk through the similarities and differences. Just put that one behind there. Mm-hmm. Okay. Bring my windows to the front, so we can again talk through the similarities and differences. So we could at this point talk about inheritance and the fact that the X and Y being present in both is because they share them from actor.
Yeah.
But the fact that size and stability is only an asteroid is because that's an asteroid specific property, and conversely reload delay count is only in rocket because that's a rocket specific property. So it gives us a lot of options to talk about structure of objects, of classes, concepts.
Yeah.
Before we've even sort of looked at any program code.
Exactly, yeah. Also, one of the things actually about the pedagogical approach to teaching programming is to make the students read the code. So for example, if we have like this application and it's completed application, and then we want actually the student to change something in the code, in order to enable the students to read the code, to get used to reading the code and understanding the code, we try to tell them, try to find something in some of the methods. So the students will try actually to read the code, try to read meaningful names for the methods and find what they want actually to do. And by that, the student actually will find it quite easy to modify things rather than writing that from the scratch.
Yeah, and this discussion often comes up a lot when people think about learning to code. There's often comparisons to literacy, learning to read and learning to write. And it's often raised that we don't start by teaching people to learn how to write. We start by learning to read. And once they've read and understood, the connection between the words and their meaning, only then does it make sense to actually start doing some writing.
Yes.
And so there's obviously questions about how much is too much. You need the code equivalent of a children's book, essentially. You want a simple example to begin with. So asteroids here that we've got is maybe a sort of intermediate example, but it's still interesting to look at what's going on. And so in Greenfoot, the way to read is often to start with the ACT method, which is kind of the core method that happens every frame in Greenfoot. So here
it's like a main method.
Yeah. So here in Rocket we've got this ACT method, and we can see what's it doing. Okay, so it's doing some movement, checking keys, checking the collision. And at this point, okay, we wouldn't necessarily do this, minute one of the programming lesson, but if they've seen a bit of code, they can start to understand, okay, this is, this calls a method somewhere else.
Yes.
They maybe don't understand every single bit of it. What's this reload delay count plus. Okay, but often it's just about learning to read code, to navigate code, to find the useful bit as part of just generally building aptitude in programming. So let's say, for example, we wanted to change the key that's being used in the asteroids project. So we might look at this and think, okay, check keys. Sounds plausible, doesn't it? So we can then scroll down to look. Check keys method is actually here. So what's this doing? Well, if you've done even sort of the first lesson of Greenfoot, you probably know the is key down method. So you can say, okay, the keys are up, left, right. Okay, space seems to be firing. So let's say we gave the students a task. Can you change the firing? So instead of space, you choose a different key. So maybe F for firing. So they might navigate their way to here.
Okay, do a little change, just
if they're lucky. Okay, do a bit of a change, and then they can go back to the main window. I might just turn I think my sound is muted. I've previously found demoing asteroids is very loud, so let's leave ourselves muted. So now if I press F, okay, so now F does the firing. So it's just a simple change that we've made. We didn't get them to start writing a complete program from scratch. We just said, give them a little task. Okay, can you find the point where this key is changed? So it allows them to learn to read and navigate code. So the writing the code is minimized. We changed space to F. It wasn't very, it wasn't very complicated. But it's just about, okay, can we get them the hang of of finding their way around the program?
Yeah, and also they can see the modifications straight away from the once you actually run the program again, so they can see the effects of change that they have made, and they feel that they have done something, which is actually gives them more encouragement actually to do something else more advanced later on as well.
Yeah, because they didn't encounter a syntax error. Trying to enter their code.
Exactly.
If you make the change very small, they should hopefully be able to manage it without syntax sort of issues. And as you say, lots of encouragement when it works to go on to do larger tasks.
Yeah. And also, one of the main things about Greenfoot, which we were talking about, and we are actually discussing that Greenfoot doesn't have the main method, that the standard main method in Java. It's written in somewhere actually by Greenfoot, but for the students actually they don't have that boring main methods in Java. So all the methods actually are readable and have got some meanings for the programmer, for the classes. So this will also help to avoid some of the what we call some of difficult concepts of Java when you start learning that. So avoid main method, start with the real methods that actually have got some meaningful names and some parameters you can modify and you can add by yourself.
Because it's often a criticism we see of Java online is that people say, oh, I use, say, Python rather than Java because, if I want to get started with Java, I've got to write class X, I've got to write public static void main, string args. It's the classic complaint against Java. But both BlueJ and Greenfoot just sidestepped it. And we say, well, you're going to start with, we're going to give them examples to begin with anyway, actual programs to tinker with. So, we don't even have the main method. It's not about writing from nothing.
True.
It's about giving them, as you say, a program that's already does something and working from there. And that's actually one of the guidelines that we were talking about, wasn't it? Is don't start with a blank screen.
With a blank screen.
Because even in Python, we talk to some teachers and they say that the scariest moment for the student is they've got this blank screen, this blank white screen with a flashing cursor, and you tell them, okay, write a program that, reads from the terminal, asks your name and reverses it, or some little example. And they just sit there at the blank cursor thinking, oh, how does this work again? It's quite intimidating, especially early on, and it can, as you say, knock their confidence.
Yeah. I mean, what also very good about Greenfoot is actually having the examples written in a way like games. And this actually gives the programming more interesting aspects, because you actually play with the things, so you have something to play, and then you modify it, you see how your actually game is developed, and this also will attract the students actually to learn to do some programming in better way as well.
Yeah. I mean, part of our theory behind building Greenfoot on top of BlueJ is, just the visual aspect. As you say, things move around, things fly around, things happen, sounds play. It's much more interactive. You get a much more interesting result out of the end of it. And we always shy away from terminal-based examples like input this string, output that string. It's kind of, there's a purity to that because it allows you to create very simple sort of concise programs, but we're just not sure about the engagement aspect of doing that. It doesn't have to be games. We also have simulations and other things in Greenfoot, but it's just the visual aspect, just getting them into what's going on a bit more is just more interesting, we feel, than sort of the pure algorithmic focus of convert this number to that number, which could be a bit dry.
Rather than only having text and then trying to modify that text and printing message to see what is the result. But here they can actually see the visual things, how it works and how it can be modified very easily.
So it's one of our sort of selling points, I guess, isn't it? It's trying to sort of increase.
One of the main also guidelines about teaching programming is using large objects. So rather than actually starting from scratch, you have like completed project. This project actually has different functionalities and quite a bit long numbers of classes and methods. And the students actually, once they get involved with that project, they actually find any other projects quite easy, because they started with large projects, they are not scared with any projects later on, and they can actually develop the projects very quickly and more confident than if they actually started from scratch. I mean, it's all to do with trade-offs, isn't it? Because if you start with a blank screen, you've not got anything there that's confusing them. If you start with a large project, you do of course run the risk that they can get a bit lost in it. And it's about, like kind of trade-off.
It's about providing the structuring, isn't it? If you design an activity with the asteroids project, you're probably going to have a worksheet or something that tells them where to look, where to go. You just have to be alert to the fact that they might accidentally blow a big hole in a piece of code by deleting a chunk. And potentially they just go back to the original version or something like that. So there's different aspects to take care of in the different styles of teaching.
It depends as well. It depends on the programming actually, on the course actually style, on the students' level. But keeping actually those kind of projects large enough will give the students over the time the confidence they need actually to develop more complex and more advanced projects.
And I mean, it's also, if you're teaching a course where you're perhaps thinking of your students going on to be programmers professionally, which is not always the case. A lot of computing courses are just giving a sample. But if you're sort of later in the pipeline and more interested in it, it's very realistic to be given a large program and have to find your way around. So when Hamza started working here, we gave him the source code to BJ and Greenfoot. We gave him a few tasks, and he had to find his way around. And
but I found it actually very useful, because if I try to actually fix a bug, I also look into different coding, different methods, and then I get used to those. So if I got another bug, then I remember I found that actually a method in that class, so I can actually fix it and do some development, etc.
Yeah, and it's a fairly standard state of programming that when you come to a code base, you don't understand it all.
Yeah, exactly.
It's not like you printed it all out and read it from start to end and work out what's going on. It's realistic that you come to a bit of code and you tinker. So especially for sort of intermediate programmers, it's a very realistic task of okay, here's some program code. Hopefully, you'll have seen the concepts before.
Yeah.
So once you've done a few lessons of Greenfoot, to then be given a larger project and say, okay, well, here's somebody's completed game. There's a problem in it. The score doesn't increase when something gets shot or whatever. Figure out what's going wrong, and it teaches them debugging. It teaches them reading code. So it's different styles of tasks that we can give them.
I think it boils down to problem solving techniques. So when you actually have like a large project and then you have a problem, then the students actually will think about that problem. So that will increase their skills in solving problems and thinking about that, where they have a complete application, but this application has got some bugs or some problems, so the student can fix it, and then he or she will feel happy once that actually fixed or sorted out.
Yeah. And I mean, the other thing that I find useful in Greenfoot is just the act of being able to code for a bit, you play for a bit. It helps break things up.
Yes.
So that your concentration isn't permanently on the program code. I imagine if you're a teacher, you're a little bit mindful as a teacher that you don't want them playing all the time, so you do have to sort of look over their shoulder a bit. But you want this feedback cycle of I did something.
Exactly. Yeah.
Hey, it's fun. I do something more. Hey, that's fun too. Oh, I've got an idea of my own.
Yeah.
Let me try that out. So just being able to go and do some modifications and have a look round. So I mean, let's do another example modification, shall we? To give another example. So can we think of anything that we want to
let's try to change the asteroid size, for example.
Okay, so let's see if we can change the asteroid size. So. Okay, we haven't pre-planned this. Perhaps we should have. So, in asteroid.
In asteroid. So
asteroid size. So makes sense. Let's start the asteroid. Okay. Oh well, straight away we've got a variable here with size. So that's pretty good. I'll just turn off our camera for a sec so you can see what's going on. So, okay, we've got a variable here, size. That's pretty good find if we want to change the size. So let's have a look down. Okay, so we've got a comment here, so reading comments should be helpful for us. Create an asteroid with default size. Let's just make that a little bit wider. Okay, random direction. Okay, so default size. So what do you reckon? Try increasing that number?
It's like 200.
Okay, so let's just try 200 there, and we'll just go back to main Greenfoot window, and let's see what happens.
Wow,
that was easier than I expected. Okay, so we've increased the size. Okay, maybe that's a little bit big. Shall we?
Yeah, maybe
split the difference. Head back down to 100. Okay, so that's pretty good. So maybe another modification we could make is we could add some more asteroids to begin with.
Right. Yeah.
Or perhaps change their position. I notice that the asteroids always appear in the top left, so it might be interesting to find out why that is. And if you've done a bit of Greenfoot, you probably know that it's in the world class where things usually get created. So let's go and take a look at that class. So we've got space, let's see what's in here. Okay, well, that's a useful variable if we wanted more asteroids. So start asteroids is 3. So again, it's about learning to read bits of code, look for meaningful things.
It's like some
tinker with it.
Small modifications to the code actually, and to start with.
Yeah, so if we change that, okay, hard to see there because they're getting all on top of each other, but there we go, we can see 5 now. Okay, so that's how to add more, and then let's have a look at where the position is.
Yeah.
Work that out. So what have we got here? We've got, okay, this is the constructor, setting some background, stars, that's probably not us, so we make a rocket, we add a rocket, asteroids, okay, so this looks like there's an add asteroids method, so we could have a look for that. I think this kind of exercise also drives home that, often even if we'd written this code, we wouldn't have a perfect sort of understanding.
Yeah.
If I just put us back on. So you don't necessarily have a perfect understanding at all times of all the code, even that you wrote yourself. And the students can sometimes get intimidated thinking they must be able to understand every single line in the code, the relationship to each other. And often, realistically, you're just bumbling around a bit, aren't you? Looking for like, oh well, that mentions asteroids. Let's go and sort of take a look at that. So just try to sort of get them used to that. And one thing you can do to help drive this home is live coding. So if you're teaching, you might put this up on a projector. So what we're recording on our video here, you might have up on the projector and just talk through what you're doing with them. That maybe you think of, get them to suggest a task, so it's clear that you haven't pre-prepared it, and then just explore it with your students to say, well, I don't know, let's go and have a look around, and let's go and see where that code might live. You do a little bit of filtering. If somebody suggests a task is really hard, you often might ask for another student to suggest a different task, or these little classroom manipulations that teachers are used to doing. So add asteroids, let's go down and see if we can do that, so I can keep that visible. So here's the add asteroids method. So it's got some sort of count. There's a loop here, which is what we'd expect. And so what's it doing? So it's getting a random number, and the maximum limit here is half the width of the world, and maximum for the y is half the height of the world. And so these two things actually explain why our asteroids always end up in the top half of the world.
Randomly.
So because the maximum x is here, and the maximum y is about here, they always end up in the top. So that's as an experiment. Let's change that. So if we try that, so say okay,
probably any place actually in the
any place in the world. So let's see how that happens. So they're much more spaced out now. Okay, but this reveals the problem with our approach. So the asteroid can now randomly spawn on top of the rocket. So if we run this scenario now, I'm pretty sure instant game over. So whoever
and this is problem solving actually. So the students will think, how do I solve this problem? Then they can actually change some of the variables or some of the parameters that have been actually passed by.
Yeah, so whoever wrote this originally, well, that'd be Michael, did this deliberately to try and avoid this problem. But they didn't put a comment.
To keep it
we should put a comment.
Rocket,
so, okay. So we might now put a comment, only spawn in the top left to avoid asteroids being on top of the rocket. The start. And so again, this also introduces another practice to students, which is write comments.
Yeah.
And often one problem with writing comments is students don't understand what comments to write at the beginning. They either get very literal and they just repeat the piece of code that was there, or they get very lazy and just write no comments whatsoever. And so actually, this is an example, I think, of a good comment in code, which is, okay, there's something slightly unexpected here that's not explained, and so when you come back to it, you might not understand what was going on here, and that's when comments become useful. Is sort of to explain the unexpected piece of code. So now that we fixed that, they should all be back to spawning in the top top left again, so our rocket should be safe.
For some time. Yeah. Also, actually, one of the guidelines that really recommended is actually to don't use hello world example, which is quite used a lot actually in any programming language. It's not because it's difficult, no, it's not, but it's probably boring, and students actually want something new. So they want actually to think about different approaches about programming and how to solve some problems in the real life or in the real examples, rather than having hello world message or any other message. So Greenfoot actually support this, and we have some examples in the scenarios that actually really fits for beginners to start with, without having just to write to print a message or something like that. But it's more advanced and more interactive ways of doing the program. And actually it highlights one of the differences between Greenfoot and sort of classic imperative programming. That, you want to have a program that you interact with, because a program that you have no interaction with is just running a pure algorithm with fixed inputs. The classic example is printing out the prime numbers. So it's another sort of classic programming task. So it's one, it doesn't involve any input, it just runs once, it prints out the prime numbers, and that's it. And there's no real engagement of like, oh, maybe I can make it print out twice the prime numbers or the square of the prime numbers. It doesn't really lend itself to, sort of more interesting extensions. Whereas if you've got a program here that is doing something more interesting, because you've got the kind of game going on, it's interactive because you actually play the game when you're doing it, you have instantly loads more ideas for what you might do to extend the program. Okay, what happens if the asteroids are twice the size? What happens if you've got 2 rockets? What happens if the rocket can shoot bullets backwards as well as forwards? There's just so many more ideas that spring forward and allows the students to kind of explore more and do more with it. Sort of extensibility. Rather than just hello world example or things like that. I think those are the main things about the that Greenfoot actually provides for pedagogical teaching approach. And of course there are a lot more things that we can consider in the future as well. But we are actually happy to hear from you about any things that you find it useful for the Greenfoot to add in the future, in order to help in improving the teaching actually process and enhancing Greenfoot in terms of making a bridge between the student and the teacher when they actually teach programming language, especially Java.
And so if you're interested in teaching with Greenfoot, if you're not already a member, if you look for our site called The Green Room, so it's greenroom.greenfoot.org, then you can sign up there and find a lot of materials and information. And if you sign up there, you can also propose topics for future sessions that you might be interested to talk about, or sort of points you want to raise about Greenfoot. So since we've spent a lot of today talking about the teaching, the Green Room is a really good follow-up resource if you want to go and sort of learn more about Greenfoot. Okay, so I think we might call it a day there, and we'll be back in 2 weeks, so that's probably going to be just into July. Well, whoever, I don't know, we haven't decided yet. Some members of the Greenfoot team will be back in 2 weeks to do another one of these sessions, so if you've got any questions for us, you can get in touch beforehand. So we hope you can join us again then.
Right, thank you so much.
Thank you.